How nuclear power plants work. A simple explanation of the fission process. Nuclear power plants are often considered impressive because they harness nuclear energy. A small amount of nuclear material can release energy equivalent to that produced by burning thousands of liters of diesel. In a nuclear reactor, there are typically tens of thousands or even hundreds of thousands of cylindrical fuel pellets. These pellets are usually made of uranium or other household oxides, which are then encapsulated in heat-resistant metal alloys to form fuel rods. Many fuel rods are grouped into pressure tubes to create nuclear fuel assemblies. These assemblies are placed in large reactor vessels made of heavy steel, along with control rods and coolant systems inside reactor buildings. When the reactor starts, a neutron strikes the nuclear fuel, triggering a nuclear fission reaction. In this process, the neutron is absorbed by the fuel nucleus, destabilizing it and causing the nucleus to split into smaller fragments. This fission releases a significant amount of energy, mostly in the form of heat. The fission also releases additional neutrons, which can then hit other fuel nuclei, continuing the fission process. This chain reaction continues in the reactor. The coolant, typically water, heavy water, or helium, flows through the nuclear fuel assemblies to absorb the heat generated. It then carries this heat to a steam generator. In the steam generator, the coolant heats up water or steam circulating outside, converting it into steam. The steam drives a turbine, which is connected to a generator, producing electricity. Although the process may seem complex, it essentially boils down to boiling water in a different way. So you might wonder, could the reactor explode like a nuclear bomb? The answer is no. Nuclear power plants don't use the same high-purity uranium as nuclear bombs, which would lead to an uncontrolled fission reaction. In a power plant, the nuclear material is separated into multiple rods, not tightly packed together. Additionally, control rods made of special materials are inserted into the reactor to absorb neutrons and regulate the chain reaction, ensuring the nuclear process remains stable. I hope this explanation makes sense. Let me know if you have any questions.